What are the first three trigonometry ratios? We're just going to cover the first three trigonometry ratios, And this is for section, let me get the right color. This is for section 8-3 and 8-4 out of your textbooks. The reason why we're doing both sections is because we're covering all three of the trigonometry ratios for the next two videos. We're going to talk about sine, cosine, and tangent. Here's a reminder of how your page should be set up. Here's video title number 1. That's the video that you're currently watching. You'll write your notes, and then you'll watch the next video, which is video title number 2. And there's no 3 for these sections of notes. Let's first figure out what trigonometry is. And this is the definition that I looked up on Google. Trigonometry is a noun, and it's the branch of mathematics dealing with the relations of the sides and angles of triangles. So for these two pictures here, this is a more advanced application of trigonometry, and it's involving the unit circle. This is what you really cover in Algebra 2. But for geometry, we're looking at this section. We're looking to see how we can build sine, cosine, and tangent ratios. So these are the first three trigonometric functions that we're looking at: sine, cosine, and tangent. And we're dealing with the relations of sides and angles of the triangles. So we're looking at all these different triangles and figuring out what's the relation between the angles and the side lengths. And here are 1 and 2 pictures demonstrating how we can apply the use of trigonometric ratios. And you're actually going to do this for your final project. You can find the height of an object, or you can find the height to an object using the degree angles, and then also being able to use the side measurements. So really, trigonometry is is a computational type of geometry. So it helps you do computations using a calculator to determine the angles or to determine the side measurements. So we're really looking at angle measurements, and it can be used of a table. All this information from a table is embedded into your calculators. So really all you have to do is enter the number and push a few buttons to get the answer. And because trigonometry used to be really hard without the calculator, with the use of a calculator, it's become very simple. So this document that I just underlined some key words from is going to be uploaded to our geometry page on our website. By the way, just a side note, you will need a scientific calculator. A basic calculator will not work. You need a scientific that has these type of functions on it: sine, cosine, and tangent. So let's determine what do these mean and how to build the ratios and use them. Remember, trigonometry is concerned with the connection between the sides and angles in any right-angled triangle. So here is a right-angled triangle, and we're looking at the angle measurement, and really we're seeing the connection or the relationship between the sides and the angle measurements. And we've been practicing that a little bit with our special right triangles and Pythagorean theorem. The sides of a right-angled triangle are given special names. So here are some right-angled triangles. The hypotenuse, which is always the longest side, the opposite, and the adjacent. So these two words are going to come in very handy. And really, when we talk about these two words, we're talking about them in relationship to a given angle. So let's take a look at this picture here. Our given angle is A. So adjacent to A would be this side here. That means that this side is going to touch the A angle, or it's right next to the A angle. And then there's the word opposite of the given angle. So if you're given angle A and that's your focus point, then opposite this angle would be this side here. So really we're looking at the relationship between all these sides of the triangle and the angle itself. Remember these these key words: opposite and adjacent. We're going to be using those a lot, especially in hypotenuse. Hypotenuse is a review, but opposite and adjacent are the two words you'll have to get used to. So remember, that is in relationship to the angle that you are focusing on. Let's take a look at this one. You're focusing on this angle A. Adjacent is the side that touches the angle A, or it's right next to the angle A. And the opposite is opposite angle A, and that's this side right here. And notice that the hypotenuse is the longest side, and it's always opposite the right angle. So if I look opposite, here's the right angle here. If I look opposite that, I get the hypotenuse. Here's my right angle. If I look opposite, I get my hypotenuse. So you can, it's always easy to figure out where your hypotenuse is. Either it's the longest side or it's opposite the right angle. So now let's define this relationship between the sides and the angles within a right triangle. And to do that, we're going to have to use the three functions from trigonometry, which is sine, cosine, and tangent. So I'll spell it out. Sine is really spelled that way with an E at the end, but for abbreviation, we just drop the E and do S-I-N. Cosine has the co but in front of sine, so then it's S-I-N-E. And we just use the C-O-S for the abbreviation. And tangent, I'll write tangent over here. Tangent, that's the word, but we only look at the first three letters of the word and just get tan. So there are three ratios, or we can even call them functions. And the reason why we call them function is because they can give us a different type of output if we give it a different type of input. Involved in trigonometry. This A, this A, and this A represent a given or chosen angle. So you can either use the angle given or you can choose a angle measurement to help to build your ratios. So let's go ahead and take a look at a right triangle. And I can put my 90 degrees here. So opposite that would be the hypotenuse at all times. And then I'm going to go ahead and I'm going to write in an angle to focus on. I'm going to use a different color. So let's focus on angle A here. Angle A. And so for sine of angle A, we would look at opposite, which is here, over hypotenuse. And I can even give some numbers to these sides. Let's call this side 3, 4, and let's let the hypotenuse equal 5. So if I have sine of angle A, I would do opposite, which is 3, over the hypotenuse, which is 5. Let's use a different color. If I had cosine of angle A, I would then do adjacent over hypotenuse. So adjacent to angle A would be 4, and the hypotenuse would be 5. And one last one, let's go ahead and use a different color. Tangent of angle A. So if I look at angle A, tangent of angle A would be opposite over opposite. I hate when that happens. Okay, there we go. Opposite over adjacent. And now there is a saying that we can use to help us remember these different ratios whenever we're looking at a right triangle or we're trying to solve a problem using the trigonometry ratios. And that is called SOHCAHTOA, or sine over which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. SOHCAHTOA. You're going to see this written at the board, and I will be referencing SOHCAHTOA when we start doing the application of trigonometry ratios, which will be on the next video.